Alright, in this video we're going to be looking at the introduction to magnetism. First, we're going to be talking about what a magnet is and what magnetic field is all about. Now, a magnet is a body possessing attractive and repulsive properties. Now, basically, when we talk about magnets, we're simply talking about bodies that possess attractive and repulsive properties. That's what magnets are. That's what magnet is. Now, a magnet can either be a bar magnet, which is the very common one. We can also have a current carrying conductor or electromagnet, and we can also have charges in motion. Magnets can be natural or artificial. An example of a natural magnet is lodestone or magnetite. Now, the artificial magnets include magnets made from magnetic materials such as iron, nickel, and cobalt. Alright, so do not forget, magnets can either be natural or they can be artificial. You can have the natural magnets to be lodestone, also known as magnetite. And then the artificial magnets include magnets made from magnetic materials such as iron, nickel, and cobalt. Now, talking about magnetic field, the magnetic field is a region or space around a magnet where the effect of a magnetic force can be felt. A region around a magnet where the effect of a magnetic force can be felt is known as the magnetic field. Alright, example can have a needle brought close to a bar magnet. Now, if we bring a needle close to a bar magnet, you discover that that needle will be attracted, alright, or will be pulled towards the magnet. That's because it's in the field of the magnet. But as we move the needle further away from the magnet, you discover that the pulling force of the magnet on the needle will decrease. Alright, so that's to say every magnet usually creates a field around it, and to describe that field we make use of what we call magnetic lines of forces. You can see here we have a bar magnet which has the north pole and the south pole. Every magnet is dipolar. They will always have a north pole and a south pole. So you can see what the field looks like. All right, to describe the field we make use of magnetic lines of forces. Here it is stated magnetic lines of forces are imaginary lines drawn in a magnetic field to show the direction of the field. So these are the imaginary lines. Okay, these are the lines of forces. We draw them in a magnetic field to show the direction of the field. All right, so they also describe the magnetic field around the bar magnet. So this is what the magnetic field around this bar magnet looks like. We have the lines of forces starting from the north or coming from the north and ending at the south pole. All right, we have the north pole and the south pole. You can see the direction of the arrows. All right, it usually starts from the north and then ends on the south. It ends on the south, please. All right, do not mind this direction here. Okay, this is supposed to be moving inward. All right, inward, 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 inward. Okay, so we have it coming from the north and ending on the south pole. The same thing here, north and ending on the south, north and ending on the south. That's what the magnetic field looks like around a bar magnet. Okay, now let's say we have an isolated north pole and or an isolated south pole, though in reality that does not exist. What I mean by that is if you have a bar magnet which has a north pole and then a south pole, I will break this bar magnet into two. Normally you're supposed to have north here and then south separated, right? But that is not possible. Anytime you break a bar magnet, the part for the north pole goes off. The other parts where the breakage occur automatically becomes south. Okay, and then for this other aspect where we have the south pole, the parts where the breakage occur will become the north pole. So every bar magnet will always have a north pole and a south pole. Every magnet will always have a north pole and a south pole. Magnets are usually dipolar. They usually have two poles. All right, so now let's say we have a north pole and a south pole placed next to each other, because unlike poles attract and like poles repel. If we have a north pole and a south pole placed opposite to each other, the north pole will be attracted by the south pole, or we are going to have attractive forces, okay, or a force of attraction. All right, and then if we have a north pole and a north pole, we're going to be having a force of repulsion. All right, this indicates the force of repulsion. There is no magnetic force in this region. All right, the same thing happens when we have a south pole and a south pole. We have a force of repulsion. All right, so basically magnets are bodies that attract other bodies to themselves, and the magnetic field is the region or space where the effects of a magnetic force can be felt. And to describe that region, we make use of magnetic lines or forces. As you can see here, all these lines are magnetic lines of forces. Now, next we are going to be talking about the magnetic and non-magnetic substances. Now, magnetic substances are substances that have magnetic properties. That is, they can attract or be attracted by a magnetic field. Magnetic substances are substances that have magnetic properties. All right, substances that can be attracted or can be attracted by a magnetic field or can attract other substances or have the potential of attracting other substances are what we call the magnetic substances. All right, and the magnetic substances can be either paramagnetic or ferromagnetic. Now, the paramagnetic substances are substances that are weakly attracted by a magnetic field. Example, we have the sodium and the aluminium. Whereas the ferromagnetic substances are substances that are strongly attracted by a magnetic field. Now, under this, we have iron, we have nickel, we have cobalt, we have steel, we have manganese. These are ferromagnetic, and then this is paramagnetic. Now, for diamagnetic substances, these are substances that are not attracted by a magnetic field. All right, they're also known as non-magnetic substances. Example, we have wood, we have glass, we have copper, we have brass, and the likes. Okay, now note, to distinguish between a magnetic substance, and non-magnetic substance, we first suspend each specimen from its center by means of a thread. All right, like I said, to distinguish between a magnetic substance and non-magnetic substance. Don't forget we've described each of these concepts. Magnets are substances that have the potential or can attract other substances to themselves. All right, and then magnetic substance are substances that have magnetic properties. Non-magnetic substance, they are not affected by a magnetic field. All right, now to distinguish them, first we try to distinguish the magnet from the magnetic substance and the non-magnetic substance. And how do we do that? All we need to do is that we first suspend each specimen, all right, from its center by means of a thread. Now, for the magnet, whenever it's suspended from its center by means of a thread, will always settle in a north-south direction. You can see stated there, the one that settles in a north-south direction is the magnet. So whenever a magnet is tied in its center and then suspended, it will tilt, and then after a while it will settle in the north-south direction. Now this is due to the magnetic field of the earth, which we are going to talk about later. All right, so if we have a magnetic substance and a non-magnetic substance, to distinguish them, we tie the each specimen. All right, we tie each specimen which we want to distinguish. All right, we tie them at their center and then we suspend them. The one that settles in the north-south position is the magnet. All right, so take note. First, we tie each specimen at the center, suspend them, and then the one that settles in the north-south position is the magnet. We then use this magnet to distinguish between the magnetic and the non-magnetic substance by bringing one end of the known magnet, all right, that's the magnet, we bring one end of it near both ends of the other two specimens. all right, which we want to determine. Now, the specimen which is not affected by the magnet is non-magnetic, all right. Remember, non-magnetic substances are not affected by a magnetic field, all right. So the specimen which is not affected by a magnet is non-magnetic substance. The specimen which exhibits attraction at both ends or affected by the magnetic field is a magnetic substance. All right. So this is just how to distinguish between a magnetic substance, and non-magnetic substance. You tie each specimen. All right. Let's say we have three of them, A, B, and C. All right. We want to distinguish between which we want to find out the one that is a magnet, the one that is a magnetic substance, and then the one that is a non-magnetic substance. All we need to do is tie these three specimens at their center and then suspend them. The one that oscillates and then tilts in a north-south position is the magnet. So if after tying them to their center and suspending them, B oscillates and then tilts in a north-south position as seen here, all right, then B is a magnet. All right. Now to distinguish between the magnetic substance and non-magnetic substance, we bring B to close to A. If B, all right, if A is attracted by B or affected by B, then A is a magnetic substance. But if A is not affected by B, then it is a non-magnetic substance. Same applies with C. Now, we also have what we call the permanent and temporary magnets. Now, the permanent magnets are magnets that can retain their magnetic properties, all right, for a long period of time. Permanent magnets are magnets that can retain magnetic properties for a long period of time. They are usually made from steel, all right. Steel is an alloy of carbon and iron. So we'll talk about permanent magnets. They are magnets that can retain their magnetic properties for a long period of time. All right. So don't forget, magnets that can retain their magnetic properties for a long period of time are known as permanent magnets. Now, the temporary magnets are magnets that do not retain magnetic properties for a long period of time. They're usually made from soft iron. All right. Materials which do not retain magnetic properties for a long period of time are known as temporary magnets, and they're made from soft iron. Now, next we're going to be talking about what magnetization and demagnetization is all about. Now, first, magnetization. Magnetization refers to the process of making a substance magnetic. All right. So the entire process of making a substance to become magnetic is what we refer to as magnetization. Now, that is, the material becomes, when we talk about being magnetic, the material becomes capable of attracting or repelling other magnetic materials. All right. So magnetization is the process of making a substance magnetic. That is, the material becomes capable of attracting or repelling other magnetic materials. Now, this can be achieved by, we have the electrical method and the contact method for magnetization. Now, in electrical method, all we need to do is we put the specimen, that's the substance we want to convert to a magnet. All right, we put it in a solenoid. All right, we put it in a solenoid and then connect it to a source of direct current. This is direct current. All right, we put the specimen in a solenoid and then connect it to a source of direct current. Okay, after a particular period of time, the specimen will be converted to a magnet. All right, so in electrical method, all you need to do is put your specimen in a solenoid. The solenoid is just a cylinder with tons of wire wrapped around it. Okay, then connected to a source of electricity. So put the magnet in the solenoid and then we connect it to a source of direct current. Okay, now every magnet will always have two poles, the north pole and the south pole. To know the polarity of the specimen, all right, after it has been converted to a magnet, we need to take note of the direction of the flow of current. Okay, if we monitor the current from one end and then we discover that the current flows in an anti-clockwise direction towards that end automatically becomes a north pole. That's why we have north. You can see the arrow moving in an anti-clockwise direction. Whereas if we monitor the specimen from a particular end and then we discover the current to flow in a clockwise direction, that end is going to be a south pole. That's why we have south pole, all right, moving in clockwise direction. Now, the contact method. In contact method, all we need to do here is stroke the specimen, all right. The steel bar here is our specimen, material I want to convert to a magnet. All right, we stroke the specimen with a magnet. And the contact method is of two types. We have the single touch and we have the divided touch. For the single touch, we use just one bar magnet, all right, to stroke our specimen. In this case, we have the specimen to be the steel bar. So we stroke it in a particular way, all right, and this is how it's being stroked, all right. You just stroke it on the specimen. After a particular period of time, the specimen becomes a magnet. Now this one is very simple. To know the polarity is very simple. All you need to do is, if you're stroking the bar magnet with a south pole, all right, you're stroking your bar magnet with a south pole, the specimen, the end of the specimen where you're starting your stroking from will become south, like we have here, all right. So here becomes south and automatically this other end becomes north. All right, so if you stroke with south, this end becomes south and then here becomes north. So we have south to south. Now, whereas for this one, if you're stroking for divided touch, you're going to be making use of two magnets. You stroke for both from both ends simultaneously in the same manner as this. But the difference here is, if you're stroking here with south pole, automatically this end becomes north. If you're stroking here with north pole, this end becomes south. So that's for divided touch method. Now, demagnetization is the opposite of magnetization. It has to do with a process whereby a magnet is made to lose its magnetic properties. Now, this includes the electrical method. Now, in demagnetization, like we said, we make the magnet to lose its magnetic properties. In electrical method, all you need to do is put the magnet in a solenoid, all right, like we did in magnetization. But in this case, you're going to be connecting it to an AC source, alternating current source, all right. So if you do this, you're going to make the magnet lose its magnetic properties. Another method of demagnetization is the mechanical method. This has to do with using a hammer, all right. It's also called hammering. You use a hammer, you place your magnet in an east-west position as seen here, then you use the hammer to hit it very hard repeatedly. After a particular period of time, it will lose its magnetic properties. Now we also have the heating method. This has to do with subjecting the magnet to heat at very high temperatures. All right, so these are the method of magnetization and demagnetization. With this, we have come to the end of our brief introduction to what magnetism and magnet is all about.